Regardless of where your DHCP server is deployed, there will be a negotiation process that happens between the client and the server. And this negotiation process is known as the DORA process, D-O-R-A. The D stands for discover, the O stands for offer, the R stands for request, and the A stands for acknowledgement. These are the four primary DHCP messages that are utilized during this negotiation process between a client and a DHCP server. So this is a server-client relationship that's happening here. The client is requesting the services from the server, and those services happen to be IP addressing. I want to look at this in real time between a PC within our environment and a DHCP server. So we're going to focus on PC1 in this example, and DSW1, which is a multi-layer switch currently configured as a DHCP server for us. So we're not using the DHCP server in VLAN 100 right now. We're using DSW1. I'm going to turn on debug IP DHCP server packet. So we're going to debug DHCP messages that are coming to and from this particular DHCP server, because I want to examine that DHCP discover, offer, request, and acknowledge. But I also want to examine it from the perspective of PC1 as well. And in order to do that, we are going to have to launch a Wireshark capture. That's what we're going to launch here, a Wireshark capture to get this going. So let's set ourselves up for this capture. We only want to capture boot P messages, which are DHCP messages. So I'm going to filter that for boot P. In addition to that, we're going to have to change how PC1 is acting. Currently, PC1 is receiving its IP address statically, and we can look at that within the properties. 10.1.1.10, that's the subnet mask, and that's its default gateway. So within Wireshark, let's start our capture. We can see that we're going to capture on the interface of which is called PC1. That's how I've named it, to keep track of everything that's going on. And right now, nothing's happening in regards to DHCP. Let's go ahead and change how we are going to obtain our IP address. So we want to obtain the IP address automatically now, meaning that DHCP is now enabled. We'll click OK, we'll click OK, we'll click Close, and there we go. There's the discover, offer, request, and acknowledge, just like that. And PC1 should now have an IP address from a DHCP server. Let's take a look at that. So before the IP address was 10.1.1.10, let's take a look at what its IP address is now. We can see that it's 10.1.1.34. 10.1.1.34. So it received that from the DHCP server. And if we go back to that DHCP server, which is DSW1, and we shut off our debug, and we look through what is going on here, from the debug, we can see that the server received the DHCP discover message. Oh, here's the one we wanted right here, the DHCP discover message from the MAC address that ended in 06D6. That's PC1's MAC address. Therefore, we sent an offer out based on that back to 06D6. We received the DHCP request from PC1, and then we send the DHCP acknowledgement back to PC1 as well.